Hi, this video will discuss cost minimization to help a firm choosing its optimal input bundle. So a previous video, which I've called Cost Minimization Part 1, discusses the following approach: the cost minimization using the lowest ISO cost rule. This video, which I'll call Cost Minimization Part 2, goes after the second bullet point, or maximize your output subject to a given cost spending. This is also known as a tangency rule. So there's two key pieces of information that you need to cost minimize. You need an ISO cost curve. You need isoquants. And so in this approach, maximize output, or the tangency rule, it says for a given level of spending, a given budget for a firm, which we call ISO cost, choose the isoquant that lies furthest from the origin. And this is the optimal bundle is going to be where these two curves are just tangent. One's a curve, one's a line, but you get the idea. So here's the image. We have, maybe their spending is going to be $2,000. The firm wants to spend $2,000, and it wants the isoquant that lies furthest from the origin, or has the largest amount of output. So this is just one isoquant driven sketch on this graph, but there are an infinite number of isoquants. There's an isoquant that lies inside this one. This is meant to be of the same shape as the pink one here, for example, and maybe that isoquant here that I've drawn inside is an isoquant of, say, 80. And there's another isoquant out here that's supposed to have the same shape as the pink one. And this may be an isoquant here. Everywhere on this isoquant is 120. And so if you're spending $2,000, you're on this blue line. Can you produce 80? Yeah, you could produce 80 here and produce 80 here. Well, can you get more than 80 spending $2,000? Yeah, you can just get this point X here is just tangent. That's the optimal. Getting 100 units of output, spending $2,000. Now, can you get 120 units of output spending $2,000? Well, no, because nowhere does this isoquant is tangent or intersects this $2,000 ISO cost. So we can't do it, not with today's technology. So to recap then, the optimal bundle is this tangency here at point X. The tangency is between your ISO cost, the blue line, and that slope of the blue line is right here, negative W over R. And that slope is just equal to the slope of the isoquant. Well, the slope of the isoquant, there's a term for that, and that's called MRTS. There's a separate video on MRTS. Well, the MRTS slope is also this ratio of marginal products, MPL over MPK. So where these two guys are equal, these two slopes are equal, or where it's just tangent, that will be the cost minimization way of choosing the largest isoquant that you can afford by spending $2,000. This is the highest isoquant that's furthest from the origin, the tangency rule, here at point X. This is the cost minimization way for the firm.